Good morning, students. My name is Samuel Chukwuemeka. In this video, we shall study the applications of linear equations, and we shall specifically study mixtures. Why are we learning this? There are so many applications of mixtures. A nurse or a doctor needs to mix the right amount of drugs or injection to be given to a patient. Somebody who works in the brewing industry, like industries that make alcohol or soda or antifreeze solution, they need to mix the right amounts of the ingredients. Most of the chemicals or most of the food that we eat is due to mixtures, mixing several components, several ingredients to get the right taste. So we shall look at the several applications of this, and you will now see an area where linear equations are important. We can mix liquids, solids, gases, fluids, you name it. We can mix anything, just about anything, but we have to get the right proportion in order to get the right mix. Okay, so let's look at some examples, and we shall start with the common examples, which is mixing solutions, antifreeze solutions, alcohol solutions, and the rest of them. We are going to use a formula, and this formula is from chemistry. And the formula is that N is equal to C times V. Okay? I'm going to explain what this formula means. Now, you may find this formula in your math textbook. You may not. But if you can know this formula, it will save you a lot in understanding this. It will facilitate your understanding of these mixture problems. Okay? When we talk about solutions, at least we have three things in mind. We have C, which is the concentration of the solution. We have V, the volume of the solution. How much is it? What is the amount? And then we have N. N is what I call the number of moles. Number of moles. This is also an amount. Okay? You can also call it an amount. Now, concentration is how strong or how weak a solution is. Let's take, for instance, you go to the store, maybe you go to Walmart, and you see an alcohol solution that is 3% alcohol. And then you see another one that is 15% alcohol. So you see that the concentration of the 15% alcohol is stronger because the concentration is 15%. And then the other one is 3%, which is weaker. Okay? What if we talk of water? Water does not have any alcohol, so the concentration of alcohol in water is 0. So concentration is how, in a layman's view, it is how strong or how weak the solution is. Then we talk of the volume. How much is it? So you look at the bottle of the alcohol, you might see 3 milliliters, or you might see 5 milliliters, or you might see 5 liters. That is the volume. So you see the concentration, you see the volume, right? And then the next thing is the number of moles, or the amount. Now, the amount is when we multiply the concentration by the volume, it gives us the number of moles. Okay? Now, what do you have to know about this? In the concentration is not arithmetic addition. What do I mean by that? Let's say now you get 3% alcohol solution, right? And you drink it and you say, no, this is not strong enough for me. I need something that is strong. Now, I'm not saying you should drink alcohol, no. I'm just giving examples. So, if you say, okay, it's not strong enough for me, right? So, you will have to get something that is a stronger, a solution that has a stronger concentration to pour into the 3% to mix it. So when you pour it in, you now get a final mixture that is whose concentration is above 3%. Right? Now, let's also say you have 25% alcohol solution in a wine. Let's say you bought a wine and you have 25% alcohol solution. And you test it and you say, no, this is too strong for my brain. So that means you have to reduce the concentration, right? Now, you will reduce it by pouring a solution that either has no concentration of alcohol, something like water. When you pour water into it, which is 0% concentration, so that to dilute it, or you pour a solution that has a weaker concentration into it to dilute it. So at the final time, at the end of the day, you want to get a mixture that is less than 25% alcohol solution. You want to reduce it to maybe 17, 16, 10, something that would be okay for your brain. Now, but why I said it's not arithmetic addition is that when you have maybe 25% alcohol solution and you pour something that is 3% alcohol solution, you don't just add it. It is not arithmetic addition. Maybe 3 plus 25 to give you 28%. No, we don't do concentration that way. So just note this, okay, that when you mix solutions that has varying concentrations, the resulting mixture is not the arithmetic addition of those two concentrations. Okay, just know that. Volume is arithmetic addition. Okay, volume of the final mixture is arithmetic addition, and I'm going to explain this. Let's say you have maybe 2 liters of wine in a can, right? And then you come and you pour 3 liters of another wine into the same can. Altogether, what is the volume of the wine in the can? It's 5 liters, because it's 2 plus 3 to give you 5 liters. Okay, so when you pour something, when you have a volume of the first solution and you pour the volume of the second solution, then the volume of the final mixture is the arithmetic addition of the volumes of the two solutions. The volume of the first plus the volume of the second. So volume is arithmetic addition. And the same thing goes with number of moles. The number of moles is also an arithmetic addition. So we shall see how these things work. Let's get started. The first example, how much pure acid is in 780 milliliters of a 15% solution? In this question, they are asking us for the number of moles, N. We know the volume. The volume is 780 milliliters. And then we know the concentration. The concentration is 15%. Usually, concentration is in percentage when it comes to solutions. When you see percentage, it means concentration, how strong or weak the solution is. And of course, volume can be in US customary units, or it can also be in the international system of units. When you see milliliters, centiliters, liters, deciliters, okay, that is the international system of units. But when you see quarts, pints, gallons, that is the US customary units. You should be familiar with these cases. So we see that our N is equal to C times V, CV, right? So our N will be equal to 15% times the volume, 780. And then N will be equal to 15% means 15 out of 100 times 780. And of course, when you multiply it and divide it, okay, you have 107 milliliters. And that is the amount, or the number of moles. Next question. Question 2. How much pure alcohol is in 150 liters of a 30% alcohol solution? So we have that N is equal to C times V, and our N will be equal to 30%, which is 30 out of 100, times 150. Okay, when we do the multiplication, we have 45 liters, which becomes our answer. Now, if you don't know how to multiply fractions, please view my videos on multiplying fractions, okay? You can simplify and multiply, or you can multiply then simplify. Question 3. Suppose that a chemist is mixing two acid solutions, one of 45% concentration and the other of 55% concentration. Which of the following concentrations could not be obtained? Now, when you look at this question, okay, let's say you have something that is 45% and you want to increase the concentration. That means you have to mix it with a solution of higher concentration, 55%. And like I said earlier, the concentration of the final mixture is not an arithmetic sum of the concentrations of the two mixtures, but the final mixture would be a concentration that, of course, that is above 45%, right? Okay, that will increase the concentration of that first solution from 45% to something above it, okay? Now, in the other way around, well, not in the other way around, another case, similarly, when you have a concentration of a solution that is 55% and you want to reduce it, right? Let's say you have an alcohol wine, a wine that has alcohol of 55% concentration. I mean, a wine that has 55% alcohol concentration, and you want to reduce it. That means you have to pour a solution of a lower concentration, 45%. And what is it going to do? In the final mixture, it's going to reduce the 55% concentration to a lower concentration, right? But you see, it will reduce it. It's not an arithmetic sum, but it's going to reduce it to maybe 54%, 53%, 50%. It will reduce it to a level that is below 55%, but that is still above 45%. So when you look at this question, the concentration of the final solution should be between 45% and 55%. It should not be lower than 45%, and it should not be higher than 55%. And when we look at the options that we are given, we will see that 57% cannot be obtained. Next question. Question 4. Suppose that pure alcohol is added to a 34% alcohol mixture. Which concentration could not be obtained? Now, when we talk of pure alcohol, it means what? 100% alcohol. I mean, rum. 100% alcohol. No other thing. Like, it's the concentration of the alcohol is 100%. And you're mixing it with a 34% alcohol solution. So, of course, the final solution, the concentration of the final solution should be between 34% and 100%. It should be greater than 34% and it should be less than 100%. So we see that our answer is 32%. Next question. Question 5. How many gallons of a 50% antifreeze solution must be mixed with 70 gallons of 10% antifreeze to get a mixture that is 40% antifreeze? Now, this is what we call practical math. I wish we are in the lab, in the math lab, that we have our pipette and burette to measure all these. You measure the volume, you measure the concentration, and you see it yourself to get the right mix. But since we are not in the math lab, I will explain this as much as I can. Of course, if you look at the concentration, you have 50% to mix with 10%. Of course, when you mix it, of course, you find the concentration of the final mixture to be between 50%, lower than 50%, and greater than 10%. You actually want to obtain 40% antifreeze. That is what maybe your employer said that you must have, you must get. You want the exact concentration in the final mixture, 40%. So how are you going to do this? Now, practically it will be easy to show you how these things work, but since this is a video, I will explain as much as I can. We are going to draw a table to look at this, and I'm going to tell you the easiest way to go about understanding it. So we have that our N is equal to CV. Now we have the first column, which we shall write solutions. Okay, then the way I usually write it, since N is equal to CV, I want N to come at the end. Okay, so I write C, V, then N. CVN. You can kind of use a CV. I know this is not a CVS pharmacy, but maybe you can kind of remember, CVN. All right. Now, the solution, we have the first solution, and I'm going to write this as solution as a short form. First solution. Then we have the second solution. And then we have the mixture. We have the mixture. Right? Okay. So the way I usually take it is, I take the thing that is already there. Okay? The thing that you're holding, the solution you're holding, or the solution that you already have, I take it as your first solution. and then I take the solution that you will add to that as your second solution. That is the way I do it. But it could be either way. Whichever one you wish to call your first solution, that is fine. Okay? But I usually take it that the solution that you already have is your first solution, and then the solution that you want to add to it is your second solution. Okay? So from the question, we now see that the solution we already have, we have a 10% concentration, 70 gallons of 10% antifreeze. So the concentration here is 10%, and 10% gives us what? 0.1. Let's change it to decimal. The volume is 70 gallons. Now let's take note of that the unit is 70 gallons. So the number of moles will be 0.1 times 70, which gives us 7. In the second solution, they are asking us how many gallons of a 50% antifreeze solution. So the concentration of the second solution is 50%, which is 0.5. But we don't know the level, we don't know the volume of this second solution that we will add. Now, why is this important actually? Because you cannot just add the entire volume. You cannot just add anyhow volume. Okay? If you want to get the exact concentration of 40%, then you will have to add a specific volume. You don't just add anyhow. Like, let's say you want to dilute an alcohol. Maybe you have alcohol that is 50% concentration, but you want to reduce it to 20%. You don't just get a gallon of water or 2 gallons of water and pour into that. It might reduce it to like 10% or 5%, below what you had initially wanted it to be. So you have to add a specific volume. That is what matters here. Okay? And that is the actual volume that we want to find. So we call it V2, V subscript 2. Okay, let me just call it V subscript 2 to show that it's the volume of the second solution that I do not know. Now, when you multiply this, you want to find the number of moles. You now have 0.5 V subscript 2. Okay? So let's look at the mixtures now. You want a 40% concentration in the final mixture. So 40%, which is now 0.4. And of course, now the volume, like I said earlier, the volume is the arithmetic sum of both of them. So this is 7A plus V2. Okay, remember, the concentration is not an arithmetic sum. No, you can't just say 0.1 plus 0.5. No, you don't do it that way. Yeah, but volume is an arithmetic sum. The same thing, the number of moles is also an arithmetic sum. But we can't just come and add it immediately, 7 plus 0.5 V2. We have to multiply this for CVN. 0.4 times 7A plus V2. That gives us 0.4 times 7A plus V2. Now, because the number of moles is also an arithmetic sum, we know that this here will be equal to this plus this. Okay? So let's go ahead and finish this up. Let's go ahead and do it. So we have that 0.4 70 plus V, the second volume, will give us 7 plus 0.5 V2. Please, this is now distributive property. You have to use it and then solve the linear equation. I suggest that you view my videos on distributive property, and then you also view my videos on linear equations to get an understanding of this. So this will give us 28 if we distribute plus 0.4 V2 equal to 7 plus 0.5 V2. So when you solve the linear equation, you have that. And if you don't understand the way it is done, please view my video on linear equations. So 21 is equal to 0.1 V2. And we have that 0.1 V2 will give us 21. So when you divide it, we have that V2 will be 21 divided by 0.1. And that gives us 210 gallons. So, in summary, what do we need? In summary, we need 70 gallons of 10% antifreeze solution to be mixed with 210 gallons of 50% antifreeze solution to give us 280 gallons of 40% antifreeze solution. Next question. Question 6. A pharmacist wishes to mix a solution that is 6% Minoxidil. I'm not sure if I pronounce this chemical right. Okay, that is 6% Minoxidil. She has on hand 60 milliliters of a 4% solution and wishes to add some 8% solution to obtain the desired 6% solution. How much 8% solution should she add? Now, you know, this is too many words. And some folks get scared when they see a lot of words in a word problem. You know, you ask yourself sometimes, why can't you just say how much 8% solution should be added to 6%, which is to mix a solution that is, how much 8% solution should be added to 60 milliliters of a 4% solution to get 6% solution. I mean, that is just rewarding it. I mean, you don't need to be scared of these so many words. You can simply say how much 8% solution should be added to 60 milliliters of a 4% solution to obtain a 6% solution, period. I mean, rather than going about all these words. But you don't need to be scared, okay? You just need to rephrase it in your own words, that will be much simpler, that will make more sense, and then you solve it. Okay, don't be scared by so many words. Try to simplify it, try to rephrase it. Okay, so let's solve this question. So we have our solutions. Then we have a CVN. Okay, so we have our first solution, what she has on hand, right? And then we have our second solution. And then we have our mixture. So the first solution, what does she have on hand? She has 4%, which is a concentration, which is 0.04. And then she has 60 milliliters, right? And if you multiply the two, it gives you 2.4. Okay? Second solution is she needs, how much of 8% should she add? 8% is 0.08. Now we don't know V2, right? So we put it as V2, and if you multiply both, it gives you 0.08 V2, right? Then what does she want? She wants 6%, of course, and 6% is 0.06. And of course, the volume is arithmetic sum, 60 plus V2. And you multiply these two guys, right? It gives you a 0.06 times 60 plus V2. So let's go ahead and solve this and see what it gives us. So we have 0.06 times 60 plus V2 to give us 2.4 plus 0.08 V2. So when we distribute, we have 3.6 plus 0.06 V subscript 2 V2 equal to 2.4 plus 0.08 V2, right? So 3.6 minus 2.4 will give us a 0.08 V2 minus 0.06 V2. And we now have that 1.2 is 0.02 V2. Let's rearrange that. 0.02 V2 is 1.2. So V2 will be 1.2 divided by 0.02, which gives us 60 milliliters. So we will need 60 milliliters actually. Okay. So in summary, let's summarize this. In summary, we need 60 milliliters of 4% solution to be mixed with 60 milliliters of 8% solution to give us 120 milliliters of 6% solution. Next question. Question 7. How much pure alcohol should be added to 2 milliliters of a 10% alcohol solution to obtain a 30% alcohol solution? Round to the nearest 10. At least this is more simpler, right? Okay, now there's something here. Pure alcohol, right? So pure alcohol is what? 100%. Just take note of that. Pure alcohol means 100%. So this is like saying how much 100% solution should be added. Yeah, that's the same thing. How much 100% solution? Okay, let's solve this, okay? So, as usual, we have our solutions. Then C, V, N. So we have our first solution, right? Then we have our second solution. Then we have our mixture. So, concentration of the first one, what do we have at hand? 10%. And 10% is what? 0.1. Volume is 2. When you multiply it, it gives you 0.2. Second solution, what is the concentration? Pure alcohol. Pure alcohol is 100%, which is 1. We don't know the volume. We are asked to find the volume. So 1 times V subscript 2, V2, V subscript 2. And what do we want to have? We want to have 30%, which is a 0.3. The volume is an arithmetic sum, 2 plus V2. And then when you multiply that, it gives you 0.3 parentheses 2 plus V2. Right? So let's go ahead and solve this. So we have that 0.3 parenthesis 2 plus the second volume is equal to 0.2 plus V2. So when we distribute 0.6 plus 0.3 V2 to give us 0.2 plus V2. So 0.6 minus 0.2 will give us V2 minus 0.3 V2. 0.4 will give us 0.7 V2. We rearrange it. 0.7 V2 is equal to 0.4. V2 is 0.4 divided by 0.7. And you are told to round it to the nearest tenth. So when we round, it's approximately 0.6 milliliters. And that becomes our answer. Then let's summarize. What will you summarize? How would you say it? In summary, 2 milliliters of 10% alcohol solution mixed with 0.6 milliliters of pure alcohol will give approximately 2.6 milliliters of 30% alcohol solution. Next question. Question 8. Water must be added to 20 milliliters of a 4% Minoxidil solution to dilute it to a 2% solution. How many milliliters of water should be used? Now, our reference here mainly is water. In the other question, we talked of pure alcohol. Anything pure antifreeze is 100% antifreeze. Pure alcohol is 100% alcohol. Now, when we talk of water, water is used for dilution. Water is 0%. It is 0% antifreeze. It is 0% alcohol. So our concentration will be 0 for water. Okay, let's solve the question. So as usual, we have a solution. We have C, V, N. So we have our first solution, what we have on hand. And of course, we have our second solution, which is water. Our second solution is water. And then we have our mixture. So the concentration of the first solution, 4%, which is what, 0.04. And we have 20 milliliters of those. When you multiply it, it gives you 0.8. Then water is 0% concentration. That gives us 0. And then we have the volume of water, which we don't know. How much water should we add? We don't just pour 100 gallons of water just to dilute it. We want it at 2% solution. We want the final mixture to be exact at 2%. We don't want any mistake. So we have to find the appropriate amount of water to add. So 0 times V2 is 0. And then the mixture is 2%. We want 2%. 0.02. And of course the volume is arithmetic. 20 plus when you add it. And then when you multiply this, it will give you 0.02 parenthesis 20 plus V2. Okay, so what we got now? We now have that 0.02 parenthesis 20 plus volume of water equal to 0.8 plus 0. We distribute. This gives us 0.4 plus 0.02 volume of water equal to 0.8. So we move the constants to the right hand side, 0.8 minus 0.4. So we have that 0.02 V2 is equal to 0.4, and then the volume of water will be 0.4 divided by 0.02, which gives us 20 milliliters. So in summary, what do we have in summary? We have that when you add 20 milliliters of a 4% minoxidil solution with 20 milliliters of water, then you will have 40 milliliters of a 2% minoxidil solution. You can also say it this way: a 20 milliliters of water added to 20 milliliters of a 4% minoxidil solution will give 40 milliliters of a 2% minoxidil solution. Okay, even if this formula, the table and the formula also works for sometimes when you have solids as well. So I'm going to stop here, and this video will, this topic will have another video, part 2, so that we can see some other word problems. You know, these word problems I did are similar, kind of similar. Now we have some other word problems that are worded differently, so we want to look at those as well. But because of time, I want to keep this video short, at least under 1 hour. We shall break this video now, and we shall do the next video. So watch out for the next video, okay? Thank you for listening, students, and you have a great day.